Welcome to Econ 101. In this course, we shall first begin with microeconomics. So the main actors in the economy are consumers, firms, and the government. In microeconomics, we study individual consumers and individual firms. Later in the course, we shall do macroeconomics, which is looking at the economic system as a whole. Modern microeconomics is based on marginalist analysis. For consumers, it's the analysis of the utility functions. Now, these consumer utility functions are assumed to have diminishing marginal utility. That is, the second derivative of utility with respect to consumption is negative. Or, as the economists call them, the utility functions are concave. So the idea here is that your utility in this setting increases as you consume more, but the rate of increase decreases as your consumption increases. So if you consume one more unit, let's say your utility increases by 2 utils. But as you become wealthier and wealthier, when you consume one more unit, your utility may increase only by 1 util. So more consumption is still better for you, but the benefit that you get in terms of utility increases at a smaller rate as your consumption increases. So that is the basic utility function. Now, consumption decisions for consumers extend over multiple periods. So it is not only choosing the amount of various different goods to consume in one period, they also have to make savings decisions. That is, how much are they going to save today for future periods. So saving is transferring consumption from the present to the future. So they have to make a decision how much consumption to transfer. Now, savings decisions are based on consumers' expectations about the future. So they do not have perfect knowledge of the future, but whatever knowledge they have, they make decisions the best they can given that knowledge. So we have a theory for understanding individual demands, how much consumers want of particular goods, and what about the aggregate demand? Well, that is the sum of individual demands. So you look at individual demands for a good and you add it up. And that assumes that one individual's consumption is not affected by another's. So you can add up the individual demands to get the aggregate demand. How much you are consuming is not going to affect how much I want to consume. So here's the typical demand curve. Price is plotted on the y-axis and demand along the x-axis. What you see here is that as price increases, the demand falls. Whereas if price decreases, the amount demanded increases. Now we come to a measure of the sensitivity of quantity demanded to price. It is called price elasticity of demand. It is defined as the change in quantity divided by the change in price divided by price, and that is equal to the percentage change in quantity divided by the percentage change in price. So this is the most common way to define it. Percentage change in quantity divided by percentage change in price. So you see in the equation of price elasticity, it is not the straightforward derivative. It is not dq by dp. Rather, it is dq divided by q divided by dp divided by p. The advantage of that is that it makes elasticity dimensionless. So we can talk about elasticities without bothering what units, quantity or price are measured in. At any price P, the elasticity computed will differ based on the change that is happening in P and the consequent change in Q. So the correct elasticity is for a very small change in price and quantity. However, that may not be available, and we can try for a better approximation by taking averages. For example, if the price changes from P1 to P2 and the quantity changes from Q1 to Q2, then we can compute the percentage change in quantity as Q1 minus Q2 divided by not Q1 or Q2, rather the average of Q1 and Q2. Similarly, the percentage change in price as the change in price divided by the average price, P1 and P2 divided by 2. So then we would have the elasticity formula to be Q1 minus Q2 divided by Q1 plus Q2 divided by P1 minus P2 divided by P1 plus P2. And of course, if we had a change in price in both directions rather than just in one direction, then we would get an even better approximation for elasticity. Now here's an example of price elasticity. You have the price of peaches to be $1.99 per pound, and let's say the total quantity demanded is 3 million pounds. Now suppose there is an increase in price to $2.09 per pound and the quantity demanded falls to 2.75 million pounds. So the question is, what is the price elasticity of demand for peaches? And the answer from the equation that we had in the previous slide will be 3 minus 2.75 divided by 3 plus 2.75 divided by the change in price divided by average price, and it turns out to be minus 1.77. The higher the price elasticity, greater will be the change in quantity demanded for a given change in price. And then the good is said to be more elastic. So if you have high elasticities, there's more change and the good is said to be more elastic with respect to price. And elasticity of zero, on the other hand, means that there is no change in Q at all for a change in price. So the demand curve is vertical. There is no change as you change price along the y-axis. Demand remains straight. So the demand curve looks like this. If the demand curve is horizontal, on the other hand, this is most elastic. It means that even small changes in price are going to have a great impact on quantity. Typically, the price elasticity of demand will change over the demand schedule. For example, over here, we have the price elasticity to be less elastic in this region and more elastic in this region. Now, in the example that we had, the price elasticity was minus 1.77. Now, what about total expenditure on peaches? Well, before the price change, the amount being spent on peaches was 3 million pounds into $1.99 per pound, or that was $5.97 million. And after the price change, this fell to 5.7475 million. So the increase in price of peaches decreased the total amount being spent on peaches. Indeed, we can show that whenever the price elasticity magnitude is greater than 1, then if price increases, it will reduce the total amount of money being spent on the good. So it will reduce the money. And one convention is to call this an elastic demand. So if the magnitude is greater than 1, which it was in our example, it was 1.77, then the increase in price resulted in the total money being spent on it going down, and then we would call that an elastic demand. If the magnitude is less than 1, that means that the quantity being consumed is relatively insensitive to changes in price, then the total money spent will increase as price increases. So here what will happen is that the price will increase, but the quantity consumed will not fall very much because the demand for that quantity is relatively inelastic. For example, if you are using your car to go to work and the price of gas increases, your demand for gas would be relatively inelastic. You are not going to change the quantity that you consume, and the total magnitude, the total amount that you spend on gas will increase. Now we define income elasticity. It is the percentage change in quantity demanded divided by the percentage change in income. So it's a measure of how sensitive quantity demanded is to changes in income.